Imagine a world where machines think, learn, and reason like us. How do they do it? Let's start our journey with knowledge representation and reasoning in AI. In the vast universe of artificial intelligence, there lie two core constituents that power the intellect of machines: knowledge representation and reasoning. Picture knowledge representation as the brain's library, where information is stored in a comprehensible and structured way. It's the method by which AI systems can grasp the world around them, encoding knowledge into a format that machines can work with. But what good is a library without a librarian? That's where reasoning steps in. It's the process of using this stored knowledge to make decisions, draw conclusions, and generate new knowledge, much like the human thought process. Together, these two elements form the foundation of intelligent systems, enabling machines to simulate human-like thinking. In this video, we will embark on an intriguing journey, decoding the secrets of knowledge representation and reasoning. We will delve into the different methods of knowledge representation, from semantic networks to frames and ontologies. We'll explore how machines use reasoning to make decisions and generate new knowledge. We'll illustrate the concept of knowledge graphs, a powerful tool that connects information in a meaningful way. As we move along, we'll also touch upon the practical side of things, discussing how these concepts are utilized in various sectors, from healthcare to finance. We'll demonstrate how to create a simple knowledge representation model and dive into the world of semantic web technologies. Not to mention, we'll also hear from experts in the field, adding depth to our understanding. Our voyage doesn't end there. We'll look into the future, exploring emerging trends in knowledge representation and reasoning, and discuss the real-world impact of these concepts in enhancing decision support systems and AI applications. So, are you ready to dive deep into the realm of artificial intelligence thinking? Scene script. Knowledge representation is the brain of AI. Now let's decode it. Knowledge representation, or KR, is a fundamental aspect of artificial intelligence. It's the method by which machines store, organize, and utilize information, essentially acting as the brain of an AI system. Just as we humans store information in our brains, AI systems use knowledge representation to store and structure data. There are several types of knowledge representation, each with its unique strengths. Semantic networks, for instance, visualize relationships between concepts. Imagine a web where each node represents a concept, and the connections between nodes represent relationships. This structure allows AI to understand connections and associations, much like how our brains link ideas together. Next, we have frames, a type of knowledge representation that groups related information into a single unit or frame. It's akin to how we categorize information, like knowing that apples and oranges are both fruits. A fruit frame would include both apples and oranges, along with other related information like edible and grown on trees. Ontologies, on the other hand, provide a structured model of a domain. They define the types, properties, and interrelationships of entities within a specific area of knowledge. Think of it as a comprehensive map of a subject area, offering a detailed overview of all its components and how they interrelate. But how does AI use these types of knowledge representation? Well, it's all about making sense of data. AI systems use these structures to understand information, find relationships, and extract meaning. Whether it's a chatbot understanding a user's request or a self-driving car interpreting traffic data, knowledge representation is what enables AI to understand and act upon the information it receives. In a nutshell, knowledge representation is the structure that allows AI to mimic human thought processes. It's the foundation upon which AI builds its understanding, leading to intelligent responses and actions. That's how AI systems store knowledge, but how do they use it to make decisions? Let's find out. Reasoning is the heart of AI decision-making. Let's unveil it. In the realm of artificial intelligence, reasoning is the process that allows machines to simulate human-like decision-making. Picture a game of chess. An AI system uses reasoning to evaluate the current position of all pieces, analyze the possible outcomes of various moves, and then selects the most advantageous one. This is accomplished through a process called inference, where the AI draws conclusions based on the knowledge it has represented. For instance, if the AI knows that all apples are fruits and a Granny Smith is an apple, it can infer that a Granny Smith is a fruit. Inference and reasoning together give AI its decision-making prowess, equipping it to solve complex problems, understand natural language, and even diagnose medical conditions. All this by interpreting structured knowledge and making logical deductions, just like a human brain. Now that we understand how AI thinks, let's explore some real-world applications. From healthcare to smart assistants, knowledge representation and reasoning are everywhere. Let's see how. Imagine you're visiting a doctor who has access to a vast, interconnected web of medical knowledge. As you describe your symptoms, the doctor's intelligent system leverages knowledge representation and reasoning to understand your condition, cross-referencing your symptoms with potential illnesses and even suggesting possible treatments. This is the power of AI in healthcare, where knowledge-based systems are revolutionizing medical diagnosis and treatment planning. Now let's think about smart assistants. Ever wondered how your voice-activated assistant knows the answer to your countless queries? Well, it's all thanks to knowledge representation. These assistants store and organize information using knowledge graphs, answering your questions by reasoning through this structured data. They understand your requests, map them to relevant information, and generate responses that are, more often than not, exactly what you were looking for. Knowledge representation and reasoning aren't just limited to healthcare or smart assistants. They're integral to the functioning of knowledge-based systems across a myriad of industries. From finance, where these systems aid in risk analysis and investment strategies, to education, where they help in personalized learning and tutoring. In every field, these systems store and structure information, reason through it, and make informed decisions. They're like the brain of an organization, holding a wealth of information and using it to make intelligent choices. So whether it's deciding the best treatment plan for a patient, answering your burning questions, or making strategic business decisions, knowledge representation and reasoning play a crucial part. Impressive, isn't it? Now let's see how we can create our own knowledge representation. Scene script. Ready to create your own AI brain? Let's do it. First, we'll need to pick a tool or language for our knowledge representation model. There are many options out there, but for simplicity, let's use RDF-Lib in Python. It's an easy-to-use library that allows us to create and manipulate RDF graphs. Perfect for our needs. We'll start by importing RDF-Lib into our Python environment. And breathe easy, even if you're new to Python, you'll find this exercise quite engaging. Now let's create our first RDF graph. Picture this graph as a mental map of a machine, connecting different pieces of knowledge. Each connection, or triple, consists of a subject, predicate, and object. The subject is the who, or what. The predicate is the doing, or being, and the object is the what, or whom. For example, let's consider the statement, Paris is the capital of France. Here, Paris is the subject, is the capital of is the predicate, and France is the object. Simple, right? So let's create a triple in our RDF graph using RDF-Lib. We'll code in Python, and voila, we've just added our first piece of knowledge to our AI brain. But of course, an AI brain is much more than just one fact. Let's add a few more triples to our graph. How about we include some information about famous landmarks in Paris, like the Eiffel Tower and the Louvre? Remember, the more interconnected our knowledge is, the more powerful our AI brain becomes. And there it is. You've just created a simple knowledge representation model. By adding more triples and interconnecting them, you can make your AI brain as complex as you'd like. Now, I encourage you to experiment. Try building your own knowledge representation systems. Add different types of knowledge, interconnect them, and see how your AI brain evolves. Congratulations on creating your first AI brain. But what does the future hold for knowledge representation and reasoning? The future of knowledge representation and reasoning is exciting. Let's glimpse into it. As we hurtle towards a future driven by artificial intelligence, the role of knowledge representation and reasoning continues to evolve. In the forefront of these changes are emerging trends that promise to transform the way we understand and interact with intelligent systems. One such trend is the integration with machine learning. Picture this: an intelligent system that not only stores and reasons with knowledge, but learns from it, becoming more adaptive and efficient over time. We're talking about a blend of symbolic AI and machine learning, where systems learn to reason in ways that mimic human cognitive processes, making them more intuitive and effective. Another promising trend is the expanding use of knowledge graphs, connecting vast amounts of information in ways that make sense to both humans and machines. As we step into this exciting future, let's remember the power of knowledge representation and reasoning in shaping the AI revolution.